Has anyone in the audience or any of the judges ever had to change the oil in your car? I have. Right? You have to change oil because you have mechanical gears, and these mechanical gears are touching and rubbing, so they need lubrication. You know, lots of systems actually need lubrication and use mechanical gears, from wind turbines to aircraft, even spacecraft and lunar rovers. But it's a much bigger deal when you have to change the oil in a spacecraft. It's a much bigger deal when you have to change the oil in a wind turbine. In fact, it costs about $200,000 to change the oil in a wind turbine. It's a major reason why wind energy is still not cost competitive with fossil fuels. It breaks down and needs an oil change every 7 years. What we need is a revolution in gearbox technology. And about 20 years ago, a researcher in the United Kingdom came up with a crazy concept. They said, what if we did a completely magnetic, non-contact, lubrication-free magnetic gear? But the one that they built was big, it was expensive, it was bulky, it was really not commercially feasible. My research is all about how do we take that idea and we lower the cost and we make it commercially feasible. The way that we set about doing that is a sort of a three-step process. The first step is we need to understand how it works. And we do that by creating a set of equations or physical models that we need to solve in order to model the magnetic gear. The second step is actually solving those equations. And it turns out that it's very hard to do that. We burned a lot of RAM on the A&M supercomputer for months and months, and I had to write machine learning algorithms to just be able to sift through that data. But what the results of those machine learning algorithms and all that data told us is what are the key ingredients to making the best magnetic gear possible. So then step 3, and this is the most important step, is actually building that magnetic gear and getting experimental data to make sure that my models make sense. And so this is one of the first ones that we built. This one was funded by NASA because they needed a gearbox for future lunar rovers that could go to the dark side of the moon and work for about 10 years. And what we saw when we compared the experimental data next to the closest mechanical equivalent gear is we were actually getting more torque for the same weight. We actually beat the mechanical gear. This has received significant industry and government attention. For example, General Electric, the leading manufacturer of wind turbines, reached out and wanted to partner with our lab. They recognized that despite the magnetic gear costing a little bit more up front, after the total lifetime of the wind turbine, they estimate that it could reduce the levelized cost of wind energy by as much as 20% just by replacing the old mechanical gearbox with this new magnetic gearbox. We're now currently in engagement with Amazon Prime Air. They told us that if you put in the gearbox, they can lower the speed of the propellers and significantly reduce the acoustic noise. This is a revolutionary technology that's a key enabler for the energy transition. Thank you.